Students, here we are ready to go on to the next lesson. I hope you have a really good day and I wish you a good weekend in advance. But it's time to really pay attention, and we're going to extend what we were doing and talk about eliminating fractions. We're also going to talk about eliminating decimals to make your problem easier. Yes, we could do a least common denominator, and yes, we could work in all fractions. However, there is an easier way, so that's what today's lesson is about. We're also going to talk about coin word problems. So in front of you, you should have a blank sheet ready for you to add, so you know that everybody is starting with the same problem and we don't get any scribe errors for writing down the right problem. Okay, so we're looking at this equation that has some fractions in it. Now, I did mention that idea of a least common denominator. We do still have to consider what a least common denominator is, and we have to figure out what that least common denominator would be. So if we were working in fractions, the smallest number that 3 and 2 both go into is 6. So our least common denominator would equal 6. It's the least common multiple of the denominators. So 3 times 2 is 6, 2 times 3 is 6, and if we put a denominator here, 1 times 6 is 6. All of those numbers will go into 6 evenly. We find that number just so we know what we're going to multiply both sides by. So to get rid of the fractions so you don't have to see them anymore, you're going to take each side of the equation and multiply by 6. So when we multiply both sides of that equation by 6, you might think, well, that doesn't look any easier. How's that going to help? Well, that's going to help because when we do that and we start distributing, if I take 6 times x over 3, the 3 and the 6 will cancel out, and I'm going to be left with 2x. So this part turns into 2x. 6 times x over 2 will cancel out the 2 and the 6, and that becomes 3x. So minus 3x. And that equals 4 times 6, because the main thing in algebra is that you have to, if you do something to one side, you have to do it to both sides. Now we can simplify like we had been doing before. 2x minus 3x is negative 1x. So some of you just know that if negative 1x is 24, x is negative 24, but in case you need to have a step in there, we could divide both sides by negative 1, and you get the answer as being negative 24. So our goal here in picking that least common denominator is going to be to get rid of the fractions so you don't have to deal with them anymore. So that makes your work easier. My answer here is negative 24. Okay, let's look at the next one. All right, on this problem, you have denominators of 4 and 3 and 12. So think for a minute what the least common denominator would be. Well, let's see, what's the smallest number that 4 and 3 and 12 all go into with no leftovers? That least common denominator, the least common multiple of the denominators, would be 12. Because 4 goes into 12, 3 goes into 12, and 12 goes into 12. So to make this work out very nicely, we're going to multiply both sides of this equation by 12. And you're going to start to see that when we do this, we are consistently going to end up with no fractions to deal with. So 12 times 3/4. 12 times 3/4. The 4 will cancel with this, and I'll be left with 9a. 12 times 1/3. The 3 cancels with the 12, and that leaves me with 4 times 1, which is 4. 11 twelfths times 12. The 12s will cancel. And you're left with just 11. And at that point, that's when you can easily do the problem. Okay, you would remember that you need to subtract 4 from both sides. So 9a equals 11 minus 4, which is 7. Then you would divide both sides by 9. And yes, it is okay to have a fraction for an answer. So our answer here is a equals 7/9. So we have our fraction for our answer, but we eliminated the fractions early on, so it made our work finding that 7/9 much easier. Okay, we're going to keep on going. Make sure that you're writing all these things down. Okay, here we need to think, what is the smallest number that 8 and 2 and 4 all go into? And hopefully you have thought that that number is 8, because 8 goes into 8, 2 goes into 8, and 4 goes into 8. Your key thing is making sure that all of those denominators go into this other number, and even if you miss on the least common denominator, you can still have something that works out well. So I'm going to multiply everything here by 8. This one has a little bit more to it, but we do still have these denominators that we can deal with. Over here we have to also multiply times 8. All right, so when I multiply 8 times 4y minus 4, this is in a group, over 8, the 8's will cancel out, and I'll be left with this whole 4y minus 4. So multiplying here, we get 4y minus 4. Multiplying 8 times 26 over 2. You end up canceling this out, and we get 4 times 26. 4 times 6 is 24. 8, 104. Because they canceled out. So I have plus 104 right here. And then 1/4 times 8. These will cancel out. So you end up with 2 times 1, which is 2. All right, well then we're going to put our like terms together. Remember, we need to simplify before we start to put things on both sides. Well, first we're getting rid of our fractions, then we'll do this. So 4y minus 4 plus 104, these two can go together. So you have 4y plus 100. Now it should be starting to look a little bit more familiar. We need to get rid of the 100, so we'll take away 100 from both sides. 2 minus 100. Think what that would be. That would be negative 98. And then finally, I know that some of you have it on the tip of your tongue to say it, but we're going to divide by 4. Okay, so negative 98 divided by 4 will give us 2. And 4. Remainder 2 over divisor 4. And 2/4, hopefully by now you would just know that that's 1/2 because you do divided by 2 divided by 2. So 24 1/2 But some of you might be saying, wait, you made a mistake. Don't forget, negative divided by positive is negative. So we'd get negative 24.5 on that. So please watch out for those things. Eliminate your fractions first and your life is way easier. Let's do 2 more with fractions and then we'll take a look at decimals. Okay, so here we go. There is only one denominator, so that makes it nice. I don't have to do much thinking about it. I'm just going to multiply both sides by 5. The least common denominator is 5. It's the only denominator. So over here we have 5x. Here we have 2x over 5 times 5. These eliminate and you're left with 2x. Here we have 5 times 13, which is 65. Okay, so we've got these things to work, and then we need to have the variable only on one side rather than 2 sides. We mentioned this yesterday. Minus 2x minus 2x. We get 3x equals 65, and then we can divide by 3. 65 thirds. 65 divided by 3 gives you 2. Bring down the 5. 3 goes into 5 one time. Remainder 2 over divisor 3. So 21 2/3. Okay, one more of these and then we'll tackle the decimals. Okay. All right, our least common denominator. What's the smallest number that 9 goes into with no leftovers and 3 goes into with no leftovers? Least common denominator will be 9. So we'll multiply both sides by 9. 9 times x plus 1 over 9. The 9's cancel out and you're left with x plus 1. 9 times x over 3. The 3 and the 9 cancel out. So you're left with 3x minus 3x equals 36. All right, so from here, what we need to do x minus 3x, which would be negative 2x. We still have our plus 1. So we're going to take away 1 from both sides. Negative 2x equals 35. Divide by negative 2. So x is 35 divided by 2. 1, 7, and 1/2. 1 remainder over divisor, but it's negative because positive divided by negative. Okay, so what you do is you do all the steps very carefully. You follow it down until you have the variable completely by itself. So eliminating fractions helps you to arrive at that with the least problem on those. Least common denominator, multiply by both sides, then do what you know how to do from before. All right, then we move on. We're going to look at eliminating decimals now. Okay, so there's a neat trick for eliminating decimals. All right, so I'm going to be multiplying by a power of 10. Okay, I want to check my decimals and see which one has the most places after the decimal point. In other words, that goes to the smallest decimal place. This one goes to the tenths place. This one goes to the hundredths place. This one goes to the hundredths place. So I'm going to multiply both sides by 100. Your trick to it is to say, okay, the one that has the furthest decimal places, it's this one or this one. They both have 2 on the right of the decimal. Take that many zeros after the 1, and that's going to tell you what to multiply by. So I'm going to multiply everything, both sides, by 100. Okay, now remember, when you multiply by a power of 10, you're just going to be moving decimal places. So 100 times 2.4 moves the decimal place 2 this way, so I get 240x. 100 times 0.03 moves it 2 places, and it lands right here, so I get just 3x. And then 100 times 4.74 moves it 2 places this way, and I get 474. All right, and that's pretty cool because now we have something a little bit easier to deal with. I can take 240x minus 3x, so 240 of the x's minus 3 of the x's, and I get 237. So I have 237x equals 474. So I want to divide both sides by 237. So x equals 474 divided by 237. Doesn't go in once. Let's try twice. 14, 7, 4. Oh, good. It went in 2 times. So x equals 2. Okay, so not so bad once you get rid of those decimals out of your way. Okay. Let's look at this one. Let's look at our decimal places. This one's to the 10th place. This one's to the 10th place. So the furthest decimal place is going to be the 10th place. So I'm going to multiply the whole thing, both sides, by 10. 10 times 0.2. Move the decimal place 1 over to the right, so I get 2x. 0.8 times 10 moves the decimal place 1 over, so I get 8x. And then 36 times 10, well, here's our hidden decimal place. It jumps 1 over, so I get 360. Now you've got a variable on both sides. Some of you might think, oh, I'm going to take away the 2x. You can, but that will end up having a blank over here, which is actually a 0, which confuses people. So we're going to move the variable to the side away from the other number. So I'm going to take away 8x on both sides. 2x minus 8x. 2 minus 8 gives me negative 6x's. And then hopefully you're all thinking of divide by 6. Divide by negative 6, that is. Positive divided by negative is negative. And 360 divided by 6 gives you 6. But you have that extra 0, so don't lose it, negative 60. All right, so we eliminate decimals in a way that's just about as easy as eliminating fractions. Okay? All right, now I said we were going to talk about coins, so let's talk about coins for a while. Each penny is worth 1 cent. In dollars, that looks like this. Okay? So if I have P pennies, that's the number of them, the value of all of those coins is 0.01p. I'm going over this with you so that when we look at the word problems, it won't be a surprise. We talked about this just a little bit the other day. The value of a nickel is 5 cents, $0.05. So if I have this many nickels, altogether the value is going to be 0.05 times the number of nickels. A dime is worth 10 cents. Looks like this. Yes, I have this extra zero here, but it's because it helps you think of the dimes a little bit better. So if I have this many dimes, then my value of my coins is 0.10D. And a quarter, similarly 0.25. So if I have Q quarters, it will be 0.25 times the number of quarters. Okay, you probably know that, but just to make that make sense to you. Now let's take a look at some money problems. Money problems are very interesting. Okay, so you have $9.96 in nickels, pennies, and dollar bills. You have 12 more pennies than nickels and 5 fewer dollar bills than nickels. So what I want to do is I want to, first of all, say that since they're basing it off of how many nickels we have, I'm going to let n equal the number of nickels. Don't forget, I said it's important to label these things. Okay, the number of nickels. 12 more pennies than nickels. Okay, so my number of pennies, you could say pick P, but we're just number of pennies. We're going to not pick P, we're going to pick it in terms of the number of nickels. My number of pennies is 12 more than the nickels. So it's my nickels plus 12. These are the number of, it's not the value of. Okay. 5 fewer dollar bills than nickels. Okay, so here's my number of dollar bills. Okay, so this would be the number of nickels. 5 fewer dollar bills than nickels. Okay, so that means I'm going to take away 5. Okay, so this is how many nickels, this is how many pennies, this is how many dollar bills. I want to then take the value of my nickels, my pennies, and my dollar bills and add them all up to get $9.96. So what my nickels are worth is 0.05 times my number of nickels. How much my pennies are worth is 0.01 times my number of pennies. And how much my dollar bills are worth, well, wait a minute. Each dollar is worth $1. Each dollar is worth $1 times n minus 5. All right, so what I would like to do is I would like to simplify this just a little bit. 0.05n, I'm going to distribute here. 0.01n plus 12 times 0.01. Move it 2 decimal places, so 0.12 plus n minus 5 equals $9.96. All right, we've got these decimals in the way. So at this point, what we can do is we can multiply both sides by 100 because the hundredths place is the smallest. So we're going to do this. So distributing a lot, I have 5n, I have 1n, I have 100 times 0.12, which is 12. I have 100n, and I have minus 500. Over here, 100 times 9.96 is 996. So I've just gotten rid of all of my decimals on that. So 5n and 1n is 6n plus 100. I have 106n. I have 12 minus 500. 500 minus 12. Wait, you said 12 minus 500. Yes, I'm going to have a negative in there. 10, 9, 8, 8, 488. So minus 488 equals 996. Now it's getting easier. Add 488. So 106n equals 14, 18, 1484 divided by 106. Let's see. 1484 divided by 106. Well, there's 106. 2, 4, 424. Guess what? That goes in 4 times. Okay, so what does that tell me? That tells me my n is 4, which tells me that I have 4 nickels. I have 16 pennies because I did 4 plus 12, 16 pennies. And I have 4 minus 5. That's a problem. I have negative $1 bills. So somewhere I have made a mistake. Okay, here's where one of you points out that we don't have 4, we have 14 when we did this work. So there are 14 nickels. This makes more sense. 14 nickels. 14 plus 12 is 26 pennies. And 14 minus 5 gives you $9 bills. And we can go back to check that by multiplying it out. I have 14 times the number of nickels, 70 cents in nickels. I have 26 cents in pennies. So 96 cents in the coins and 9 in the dollar bills. Okay, so that's that one. So all of our work is good there. Just that little thing there where I scrolled up too much. Okay, let's take a look at just one more. This one's a little simpler. Lynn has $8.58 in quarters and pennies. If she has eight times as many pennies as quarters, how many does she have? Okay, so it's basing it off of 8 times as many pennies as quarters. So we're going to say Q is the number of quarters. and the number of pennies is 8 times as many pennies as quarters. So 8 times the number of quarters. Eight times as many pennies as quarters. Together, she has the value of how many of the quarters, how much money is in quarters, so that will be 0.25 times the number of quarters, plus 0.01 times the number of pennies. And altogether, that's $8.58. Okay, so let's simplify this a little bit. 0.25Q plus 0.08Q equals $8.58. If we want to get rid of our decimals, we multiply both sides by 100. So we get 25Q plus 8Q, when you move the decimal 2 places, equals 858. Then we add these together. We get 33Q equals 858. We divide by 33. 858 divided by 33 gives us 66. 198. 3 times 6. 18. 198. So we have the number of quarters is going to be 26. 26 quarters. Eight times 26 for our pennies. Eight times 6, 48, carry 16 plus 4 is 20. So 208 pennies. All right, so there we have it. We have how to solve the coin problems, which is related to getting rid of the decimals, and then we have also getting rid of the fractions. Okay, very good. I hope you all have a great weekend, and I will see you on Monday. Don't forget to do your homework. Bless you.